I'm going to show you my Obsidian Knowledge Graph, a second brain that I use to learn AI concepts faster and become a much better engineer. I will teach you how you can create this yourself with your own data so you can become more effective and grow faster. So how does this knowledge graph work and what's actually the point? Well, I of course run a YouTube channel with many different videos, and all of these videos contain interesting insights that I've learned myself in my professional journey as an AI engineer. So what I've done is I've taken all of the transcripts for the different videos and I've put them into a specific folder that allows an AI system to ingest those transcripts and extract basically all of the interesting structured information. So let's say that I want to understand what concepts I actually discussed in this Git workflow video so I can maybe create a follow-up video on it. Well, I can simply click on the video here, and what I'm going to do is I'm going to copy the video ID because I've made it so that this knowledge graph is easily retrievable and searchable by an AI system because everything is ID based. That means that I can actually ask an AI system to check all the video IDs on my channel, for example, using an MCP server, and then it's able to pull all of that information in and search throughout all of my videos inside of this knowledge graph. To prove that, I'm just going to paste that video ID, and you will see that now this video shows up as one of the only nodes, AI native Git versioning. What I can do now is right click on it, and then I can actually go ahead and open the local graph for this video. When I open the local graph, you can actually see that it's connected to multiple concepts. It's connected to AI agents, it's connected to Python, it's also connected, of course, to Git. And these are the concepts that the AI system that I've used to create this knowledge graph has extracted from the transcript of this video. So now I can just continue exploring my second brain and understand what ideas I've actually generated and explained about Git version control in the past. So I can simply click on this node, and then it opens up all of the related nodes to Git. So again, we can see a lot of interesting things here. We can see that AI native Git versioning node again, but we can also see AI coding systems, structured AI coding workflow, and we can see much more that will actually lead me down a great thought pattern for creating a follow-up version. For example, I can actually go ahead and click into AI coding systems. Here you can see that Gemini CLI is one of my concepts, and I've not really created a video with Gemini in a while, so it could be interesting to create a follow-up video of that Git workflow and then actually explore how well it works using Gemini. This shows you how useful the knowledge graph can be for me when I'm coming up with new content ideas, because I don't want to repeat what's already been created in previous videos, right? I want to give you all new videos with new insights, and I can basically combine different parts of videos that I've created in the past to create a new, useful, informative video from that point forward. So how can you actually create a knowledge graph like this yourself? I just switched my window to Visual Studio Code because I actually modify my vault using my code editor. The reason for this is that Obsidian works with very simple Markdown files, which can be easily modified by AI code agents that live inside of your editor, whether you're using something like Gemini, Claude Code, GitHub Copilot, Codex, it doesn't matter. All of these tools are really good at handling the Markdown format that Obsidian uses. To showcase that, I just wanted to share what my vault items look like when you look at the actual Markdown file. So let's go ahead and explore that example I gave before with Gemini. If I search for Gemini, you will see we actually have a Gemini CLI Markdown file, and there's a lot of structured information in here. You can see that it's type technology, it's in a specific category, and most importantly, it's linked to many other nodes. For example, it's linked to that AI coding systems hub that we actually saw in the Obsidian graph. And this is using the square bracket notation that Obsidian uses to actually link this specific Markdown file with AI coding systems. And the nice thing about this is that it's very easy for you to see in here how many nodes this Gemini CLI Markdown file is actually already connected with. And the great part about this Markdown file is that I'm able to add a lot of arbitrary details about Gemini CLI, including my opinions and views on how to use it, right? So for example, here you can see that there's a definition that's not in the graph itself, but can be explored by an AI agent if you ask it to actually check the contents of each individual node. To show that, I actually wanted to show another file that's at the root of my folder, agents.nd. This is a Markdown file that's automatically read by a lot of AI coding tools, and you can just add it to the context whenever you want. And this file actually describes how my Obsidian vault is structured. Basically, it refers to this vault structure overview Markdown file, and we can actually find this under agents, and there it is, vault structure overview. I'm going to open up that document here on the right because it shows you that I actually create multiple folders inside of my Obsidian vault, each with their own purpose. Now, the main folders I wanted to discuss are these four that can be found in the resources folder: hubs, concepts, technologies, and process transcripts. Really, hubs, concepts, technologies, these are the main nodes that you see in the Obsidian graph. Hubs are big nodes that connect to many different concepts. And concepts, well, I can show you what it means if I just open the folder. These are really important concepts that are actually recurring throughout a lot of my videos and the things that I teach. For example, AI cost management, AI agent extensibility, and there's a lot of concepts here that go through different parts of AI engineering. For example, Dockerized LLM deployment, as well as things like Fast API, right? One of the main Python frameworks for building solid LLM APIs. So this just shows you that we have a lot of different concepts that we kind of distribute among these different levels. So the highest level concept is a hub, lower level is concept, but then we also have technologies. If I just collapse this folder here and I open technologies, you will see that these are very specific technologies like Claude Desktop, Klein, Gemini CLI, and there we go. If I open Gemini CLI again, you can see that this is kind of how it works, right? We have a link to a hub, we have a link to multiple different concepts, and in the end, it all comes down to a technology, in this case, Gemini CLI. And now the question really is, how does the AI system actually know how to process these transcripts and create these different nodes? Well, for that, I actually have a big system prompt inside of the agents folder here. I have what I call a transcript processing agent, and this is a very extensive system prompt that would probably take me half an hour to fully explain. So I'm going to keep it simple and just let you know that this system prompt gives the AI agent all the context that it needs to actually connect the transcript to new or existing nodes and put everything in the right folders while following a specific structure for each and every Markdown file, which is super important, right? Because if I go back to the Gemini folder, you can see here that it very consistently has this syntax at the top that describes what kind of node it is and what hubs it's linked to. And you will see that this is very consistent no matter what file I open. So I can also go to technologies and open up a completely different random file. Let's go for local AI. And you can see it follows that same pattern. It has an open definition that I can actually change myself and I can add more text to it. But what's most important is that all of the linking to the different nodes is super consistent. So here too, we see the linked hubs and we see all of the different concepts. And that is how you get such a clean Obsidian graph that I showed you at the beginning of the video. But I can talk about these prompts all day long. I think it's much more powerful if we go ahead and run one of these prompts on a new video so you can see live what happens when I ingest new content. So basically, what I'm going to do is I'm going to go ahead and open up Codex. You can use any AI coding agent you want, but Codex is just something I've used for this project. And what I'm going to do now is I'm going to say execute the prompt, and I'm going to paste this prompt in here with the transcript. And then you might be wondering, well, what transcript are we going to use? Well, actually, we have a transcript ready to go here in this transcripts-to-process folder. That's why it's green. So I'm going to go ahead and paste that reference in there and then press enter. So while we're waiting for Codex to process all of this, I wanted to let you know what prerequisites there are when you're trying to do this yourself, when you're trying to create a knowledge graph of your own brain, right? Well, there's two prerequisites. First of all, it's having these really good system prompts that actually direct the AI agents to process the information properly. I'm helping you with that because I am going to share these prompts with you later in the video. But the second prerequisite is something that you are going to have to do yourself. You do need some interesting input data in the first place. In my case, I have all of those YouTube transcripts, but what if you don't have a YouTube channel? Well, there's no need to worry because almost everyone has some interesting input data for these knowledge graphs. If you are already taking notes in Obsidian, Notion, or a different platform, then this is a great way to ingest all of those nodes and create a knowledge graph out of it. If you're not taking any notes, there's no need to worry because you probably have some code projects lying around, right? You can actually also create a prompt that directs the AI agent to scan one of your repositories and then extracts all of the interesting concepts from there. All right, it seems like Codex is done. Let's see what it did. Of course, there's this whole plan that it executed, but because I'm using Git in this folder, I can actually very easily see what changes it made. So we can simply go to my branch here, and you can see that a couple changes were made. So first of all, it seems like we actually have a new technology, Claude Code. So indeed, Claude Code is added as a concept as well as OpenAI Codex, but there's something a little bit weird about this. For some reason, it's stylized it with code X with like a capital X at the end. That is not what I want, but I'm kind of glad it made that mistake because I can show you that by actually mastering your code editor, it's very easy to correct this kind of thing. Because what I actually can do here is if I just go to search, I can find all references where codex is stylized like this. All I have to do in this case is I can just mass replace all of it like so. And then one thing that I do need to do is I also have to change the file name here because, I do actually want to make sure that that's consistent here. So other than that, it looks quite good to me. You can see here that OpenAI Codex refers to a couple of hubs. It refers to other integration patterns. But to show that it actually immediately updates the real Obsidian graph, let's switch back to Obsidian. And then, of course, what I can do is I can search for OpenAI Codex in the main graph. So let's go ahead and do that. I'm going to open the main graph again. I'm going to get rid of my filters. Whoops. There we go. And then once I get rid of my filters, I can see the full graph again. And now let's go ahead and search for OpenAI Codex, like so. And you can see here actually that if we zoom in, OpenAI Codex is present, and we can indeed see all of those connections to the different nodes. And I will just continue and explore my knowledge graph. So I can go to AI coding systems, and then I can actually just see the specific Markdown file here. I can browse like that. And I'm actually able to explore this graph in two different ways. I can, of course, just keep clicking through all of these concepts and explore the Markdown files, but you can also explore the graph view. So if I go back and actually show you the graph view again of the OpenAI Codex node, I can then actually go ahead and right-click here, go to Open Linked View, click on Open Local Graph, and then I can just keep going and checking out the graph view instead. So it really depends on what information you're looking for, but you can do it in either way. Or you can, of course, ask Codex to just explore the vault for you to find specific references. So this gives you a good idea of what it takes to create a knowledge graph to actually keep track of everything that's in your head and be able to search through all of that information very effectively. If you want to create a graph like this for yourself, you can check out the prompts that I used for my knowledge graph completely for free in the link in the description below. You will have to adapt it for your own use case, but you will find that once you take the effort and time to do so, this is a great and effective way to create a second brain. So let me know in the comments down below how it went for you, and then I'll see you next time.